Hello student, today's question is evaluate integration cot z dz over c, where c is modulus of z plus 1 by 2 is equals to 1 by 3. Let us understood that what is c first and then we have to integrate the cot z dz over c. Okay, now here c is modulus of z plus 1 by 2 is equals to 1 by 3. That is C is the circle centered at centered at z0 is equals to minus 1 by 2, which is similar to minus 1 by 2 comma 0 with radius 1 by 3. Now here we can use one result, or you can say the theorem. What is that theorem? Theorem, if C is simple closed curve and f of z is inside analytic inside C and on C, then then integration f of z dz over a C is equals to 0. Right? Now here we have to evaluate integration cot z dz. So just we have to put cot z as a f of z dz. Right? So capital F of z is equals to cot z. We can write cot z as cos z upon sin z. Right? Okay. Now we have to prove that cot z is analytic, or we have to check that cot z is analytic or not. Now, first of all, we have to find the singular point of f of z. Okay. To find singular points of f of z. Right. Now, singular point are those points in which my function capital F of z is not analytic. Now how to find the singular point of this capital F of z, which can be written as cos z upon sin z? Just we have to put the denominator equals to 0. So what is denominator here? Sin z. So sin z is equals to 0. And when sin z is 0? When sin n pi. Right? So we can write it as z is equals to n pi, where n is an integer. Integer. So we can say that z takes the value 0, pi, minus pi, 2 pi, minus 2 pi, and so on. So these are the singular points of f of z. That means in this point, f of z is not analytic. Correct. Now we have to check that this point is lie inside the C or lie outside the C, where C is given as this circle, right? Okay. Now to check, Z is equals to 0, pi, minus pi, 2 pi, minus 2 pi, lie inside C or outside C. Now how to check that? Now we have the general formula to check that. What is that general formulas? Now if z minus z0 modulus is equals to r, then we say that z lie in the circle, lie on the circle, sorry, on the circle C, right? Z minus Z0, which is less than R, this says that Z lie inside the C, and modulus of Z minus Z0 greater than R. So this implies Z lie outside the C. Now, here Z takes the value 0, pi, minus pi, 2 pi, minus 2 pi. And we have the Z0 as a center is equals to minus 1 by 2. So, now, for Z is equals to 0. So, Z minus Z0, which is equals to 0 minus of minus 1 by 2, which is 1 by 2, and which is greater than 1 by 3, which is the radius. Right. So this implies Z is equals to 0, lie outside C. Right. Now similarly, you can show Z is equals to plus minus pi, Z is equals to plus minus 2 pi, and so on, lie outside C. So this implies all the singular point, singular point lie outside C. Okay, all the singular point lie outside the C. So this implies capital F of Z is analytic inside C and on C. Now why it is? Because all the singularities lie outside this circle. That means plus and minus pi, minus 5 here, plus 5 here, minus 2 pi here, plus 2 pi there, and so on. That means all the singular point lie outside the circle. That means we can say that f of z is analytic inside this circle C, right? Inside the circle C, and f of z is analytic on the boundary also, right? So so by Cauchy's theorem, Cauchy's theorem, what Cauchy's theorem says that if C is a simple closed curve, f of z is analytic inside C and on C, then capital F of z integration C dz equals to 0. So this implies integration C f of z dz is equals to 0. That is integration C cot z dz is equals to 0. So this is our the final answer. I hope you understood. Thank you.